Hello again. Today we're going to use mathematical induction to prove sine. So we left-hand side is the cosine, sum of some cosine angles, and the right-hand side is division. So we're going to prove this statement is true for n positive integer. So remember our n. So this is the equation we're going to prove. So my approach is we prove left equal to right hand side of statement. But before we do that, we need to decide what is the minimum n first. So you can see n is positive integer, so our smallest n must be 1. So I'm going to start with n equal to 1. So we choose initial n. So let's to the left-hand side is negative 1 to the power of 2 times by 2n minus 1 is a theta. So answer is left-hand side is a cosine theta, and right-hand side we do the same thing, n equal to 1. So therefore will be negative, negative, and positive. So when you do cosine, so that's a double angle identity. So it'll be 2 times by cosine square minus 1, so they cancel it out. So the answer will be cosine theta. So therefore, left equal to right. So the statement is true when n equal to 1. So that's step 1. Step 2, we're going to assume when n equal to k, statement is also true. So that means the n equal to k, we put the left-hand side is into k plus 1, the right-hand side is k. All right, so now we prove n equal to n equal to k plus 1. Statement is also true. So let's do the left-hand side, n equal to k plus 1. So that means first we do the n first, which is kth term. Then k plus 1 is a k plus 2 because the initial was the k plus 1. So therefore, the initial kth term, I'm using assumption from the equation. Assumption of statement number 2. So this is the assumption we're going to use. So we substitute the first kth term using the assumption from number 2. Then plus the next term, which is the k plus 1th term. Now I'm going to do common denominator, so which is square and 2 cosine theta. We're going to put a 2 cosine theta multiplied by that. So now we're going to simplify this. That's my highlighting here. This is the product identity. So can you see using the QCAA product identity, cosine times by cosine A times by cosine B is half of cosine A minus B and plus A plus B. So therefore, I'm going to do 2 times by half. So then cosine A minus B, cosine A plus B. So I end up 2 cancel with half. So it'll be negative k to the power of negative 1 to the power of k plus 2. Now we put together this, we're going to put these two together, become negative k, negative 2k theta. Then next one, we plus them together. I'll put a 2 outside k plus 1 theta. So that's the top. So now I'm going to, first, I'm going to do this. So can you see negative 1 to the power k plus 2 is equal to negative 1 to the power of k times by negative 1 to the power of 2. So negative 1 to the power of 2 is positive 1. So therefore, the answer is negative 1 to the power of k. So there's a 2. So therefore, I'm going to change that one to this one. So now I'm going expanding to the bracket. So expanding the bracket. So negative 1 to the power of k times by cosine 2k. Now negative 2k pi is same as cosine positive 2k pi. Why? Because I've got negative theta is equal to cosine positive theta. So we know this is a negative angle for cosine is same as cosine positive. So those two, then expanding to the next one, I'm going to use k plus 2 expanding to the next one. I'm going to copy that. I'm going to leave a k plus 2. Don't change to k. Now, then you can see those two cancel it out. So those two are exactly the same. I'll cancel it out. So the top become 1 minus 1, negative 1 to the power of k plus 2, then 2 times by bracket k plus 1 theta. Now that's exactly what a right-hand side should be when k plus n equal to k plus 1. So therefore the left equal to right. Then the statement is true when n equal to k plus 1. So therefore the statement is true for n equal to any positive integer. So statement is true, PUD. So that's a proof, another using mathematical induction to prove a pretty long statement. So it's a lot of techniques used. The first one is using the double angle identity. But don't forget the double angle identity, cosine 2 theta equal to 2 cosine theta, theta minus 1. So that's another identity. So a lot of identity are used when you prove this particular trigonometric statement. Thank you for watching, and also, can you please give us a thumbs up if you like the video, and also subscribe channel for more videos later on. Okay, I'll see you next time. Bye.